Yesterday we have studied the stages of our orbits: stationary orbit, low Earth orbit, medium Earth orbit, high Earth orbit, like that. Yeah, and we have also studied the orbital dynamism. And now, today's session is going to be escape velocity. Here, what is escape velocity? From the surface of Earth, the escape velocity evaluate at nearly escape velocity is 11.2 km per second. How we can do here means escape velocity v is equal to root over 2 gm by r is inversely proportional to the square root of distance r from the earth center. When escape velocity is inversely proportional to the square r, here just we have to assume the velocity which will need to escape the orbit to orbit of launching vehicle. And when altitude is increases, when satellite is going up, altitude is increases, their escape velocity decreases because the gravity of the earth will in the space is low compared to the surface of the earth. At low earth orbit, height is 100 km. No. Here, escape velocity is slightly lower than 11.2 km per second. But at high orbit, that is height nearly 40,000 km, escape velocity is drastically smaller. There is less. There is no small because it is present in the space. In the space, almost all objects all are floating. So there is no gravity in the space. So there is no escape velocity in that. So it is very negligible. Spacecraft usually execute step by step. We have to go for higher orbit. We need step by step altitude passing and make that fuel is we have to use the fuel just for to escape the certain particular velocity where we get struck while launching the satellite. Guys, how Chandrayana or Mangalyana reached their destination orbit? How satellite will go the orbit of Chandrayana or Mangalyana? Chandrayana not Moon or Mars. How? Okay. We don't have any direct path to go Moon or Mars. ISRO. We have to cross many elliptical orbit. Then we have to burn the engine, and then after escape velocity, then it will enter the orbit of the Moon or Mars. Okay, now step by step we will go. Okay, we'll launch the vehicle in the lower orbit first. Lower orbit first, elliptical orbit, right? Like that. When again it will come where the point is perigee, we again burn the engine here. Then again it will our launching satellite again enter the another elliptical orbit. And when again engine fire is increases, then again it will enter another elliptical orbit. Like that till escape velocity cross, then after that then it will go, just assume here, okay, just assume here this is more when it when elliptical orbit passes some escape velocity point, then our satellite will go our satellite will enter the moon's orbit like this. Again it will turn, but here burning of engine we have to in a reverse direction, means we have to we have to need to minimize here. After orbit to orbit, we have to minimize the engine here, engine of satellite. Ayyo. Just assume guys when it will enter moon like that. That's it. Here some special terminologies there. That is just you have to we have to go through. We are going here the orbits around the other orbits bodies. Okay, we know the some primary bodies earth, moon, mars, sun. Okay, we know the earth nearest point is the perigee. In the same way apogee, we know this in the previous lesson. Okay, in the same way for moon it is perilunar and farthest point is the apolunar. In the same way the point nearest to the Mars is perihelion and farthest to the point is apohelion. In the same way for Sun, it is perihelion and it is aphelion. Okay, guys, it is very interesting now. Carefully listen here. Why rockets are launched from the east coast? Okay, just assume this. Okay, this is our India. Okay, we launched the satellite from Sriharikota of Andhra Pradesh. You know, always heard in the news, launch the satellite from the Sriharikota. Right, that is east coast, not west coast. Why? What is the reason behind it? Let's go into the first reason is Earth will rotate. Assume this is the Earth. Okay, when Earth rotates from the west to east, Earth rotates from the west to east, right? Earth rotates from the west to east in the same direction. If we launch from here, and it will launch from here, and it will help to pick the launch vehicle very easily because Earth rotation and we are launching direction is also from west to east like this it has to go. I think you got when you read this, you can get clarity here. And the second thing is very important, guys. Of course, you think when we launch the vehicle here, okay, if we launch the vehicle from east, okay, what will happen if okay mission will enter in the orbit? If mission will not enter in the orbit, suppose it is failed, then although debris will need to fall somewhere now, so that's why it will fall in the ocean, not on the landmass. if it if we launch satellite from the west, then what will happen? If mission is failed, then space debris not our launched vehicle will fall on the population landmass. That's why we always try to launch from the east, but not all the satellite will launch from the east side only. Because for example, let me give one example. Israel, let us assume, okay, this is Mediterranean Sea, it is Israel. Okay, if Israel will launch from west side, not from east side, why it is launched from west side? If it is any mission fail, then that launching vehicle will fall in the Mediterranean Sea. If it is launched from the east side, then it will fall on the again populated landmass. So we all we all d- we are doing this mission for human only na. So if our mission is going to harm the humans, that is not good. That's why we always used to keep saving of save the humans being. Humans love is very important for us. In the same way, we launch the launching vehicle from Sriharikota from India and Cape Canaveral, that is USA, and Kaur, Kaurav, that is French Guiana. That's and here sounding rocket and orbital rocket difference is there. There is nothing much here. It will this satellite will the sounding rocket will not go to the orbit. Okay, but rocket orbit it will go to the circular or elliptical path. That is the main difference there.